Let's start with a simple visualization on the number line. Imagine 2 points, point A and point B, where A is less than B. Now consider all real numbers that lie between A and B. This continuous collection of numbers is called an interval. An interval is a special type of subset of the set of real numbers. Unlike a regular set that lists elements individually, an interval includes all real values between two given points. The first type of interval is the open interval, written as in bracket AB and read as open interval from A to B. It includes all real numbers between A and B, but not A and not B themselves. For example, open interval from 2 to 5 includes numbers like 2.1, 3, and 4.9, but does not include 2 or 5. In set builder form, it is written as the set of all x such that x belongs to real numbers and x is greater than A and less than B. You can imagine this as being allowed to walk between two gates, but not to stand on them. The second type is the closed interval, written as square bracket a comma b square bracket and read as closed interval from A to B. This time, both A and B are included. So, the closed interval from 2 to 5 includes 2, 3, 4.5 and also 5. In set builder form, it is the set of all x such that x belongs to real numbers and x is greater than or equal to A and less than or equal to B. It's like a fence with both ends shut. All values in and including the boundaries are part of the set. Now let's look at half-open or semi-open intervals where only one endpoint is included. There are two forms: square bracket a comma b close bracket includes a but excludes b. Open bracket a comma b square bracket includes b but excludes a. For example, the interval from 2 to 5 closed at 2 and open at 5 includes 2, 3.5 and 4.9 but not 5. The reverse, open at 2 and closed at 5 includes 3, 4.5 and 5 but not 2. These intervals are especially useful when defining boundaries that are inclusive on one side and exclusive on the other. What if an interval doesn't end? Then we use infinite intervals. Examples include open interval from A to infinity, written as open bracket a comma infinity, includes all real numbers greater than an open interval from negative infinity to B, includes all real numbers less than B. We can also combine with one closed endpoint, square bracket a comma infinity, includes A and everything beyond open bracket, negative infinity comma. B square bracket includes B but not the left end. Important note, infinity is never included in any interval because it is not a real number. Intervals provide a compact and precise way to describe a continuous range of real numbers. They are used heavily in functions, inequalities, domains, and calculus. Rather than listing values, you define the entire range with a simple notation. In upcoming sections, you'll use intervals to understand operations like union, intersection, and complement. So always remember, intervals are continuous subsets of real numbers that describe ranges, not just individual points.